So yesterday when we started section 3.14, we were talking about the product property of radicals. And today we're going to talk about dividing radicals, or it's called the quotient property of radicals. So if you'd fill these in here just as a reminder. So again, the I can statement for today is going to be I can divide square roots. A product and a quotient, here we talked about these yesterday. Remember, a product is a multiplication problem, or it's an answer to a multiplication problem. So a product has to do with multiplication, and a quotient is a division problem, or the answer to a division problem. And I made a little division sign right here. Crappy looking one, but that's the way it is. So when we're talking about products, we're talking about multiplication. When we're talking about quotients, we're talking about involving division there. So we want to write down these product properties and quotient properties of radicals. So again, these work both ways. If we have the radical of a multiplication problem, we can find the radical of the first part. Whoops, let me make that an A. And we can multiply it by the radical of the second part. The thing that does for us is it makes, generally speaking, these are a little bit smaller and a little bit easier to work with. Okay, so it makes it a little bit more manageable. But again, if it's more advantageous to put them together underneath one radical, so we can maybe make more groups of factors and different things like that, then that's great. The quotient property works in this direction as well as the opposite direction. So we can take the radical of the top and put it over the radical of the bottom. And again, the idea here is we might be able to simplify this smaller thing easier and then divide it by whatever the bottom is. Might work out a little bit better, but there are times where it's better to put the two of these together and go backwards and put them underneath one big radical because maybe something cancels or something like that. So we're going to do a quick review of the product property, and we're going to do some very easy applications of the quotient property of radicals. So we've got that quotient property sitting right up there. So this is the product property right on this one. So here's the deal. Remember, you can't simplify radical 6 because it's just a 3 and a 2. And you can't simplify radical 2 because it's just a plain old 2. But by putting one big radical and doing 6 times 2 underneath, so I'm just applying this completely and showing all of the work. So I started out right here with two separate pieces. I put it underneath one radical, and then I'm going to simplify this. I'm going to do 3 times 2 times 2. And by simplifying, what I mean is I've got to identify the factors so that I can take out groups of factors. In this case, we're doing a square root, so we're looking for pairs. I didn't have a pair in either one of them, but when I put them together, now I have a pair of 2's. So I'm going to circle that 2. We've got a 2 on the outside, a 3 on the outside. So there's the answer. Now, if you take a look at this one, I'm hoping you recognize this one. If you don't, I'm going to show you a fairly easy way to do this problem. This is written as one big multiplication problem, although it doesn't look like that to begin with. We're going to identify this as a multiplication problem of, let's just do 4 times 100. Now 400 is a huge number, but what we just did is we broke it into two very small pieces. 4, which should ring a bell, and 100, which also should ring a bell. Now we're going to break it into these two guys right here. So this would be the square root of 400, or sorry, square root of 4 times the square root of 100. Square root of 4 is 2, square root of 100 is 10. So the answer on this one is 20, and if you want to double check that on your calculator or go back and take a look at your list, the square root of 400 is 20. Alright, so that's how we can use the product property. We did that both ways, and let's take a look at this one right here. You'll notice that we've got the square root of 16 over the square root of 36. That is one big radical, so it's kind of written in this form right here. So let's see what happens. Rather than dealing with this ugly fraction that doesn't look like much fun, let's do this. Let's do the square root of 16 on the top and the square root of 36 on the bottom. Now I'm hoping that 16 and 36 look familiar. They should, because that's a perfect square of 4. So the square root of 16 is 4. And that's a perfect square of 6, so the square root of 36 is 6. Now we've got a fraction that we can simplify. So 2 goes in here twice, 2 goes in here 3 times, so the answer on that one is 2/3. Okay, now you may recognize, and again I'm going to do this more than one way, you might have said, well, wait a minute, couldn't we just do this? 2 goes in here twice, 2 goes in there 8 times, and 2 goes in there, let's see, that would be 18 times. 2 goes in there 4 times, and 2 goes in there 9 times, and then let's break this into the square root of 4 over the square root of 9. Well, that would be 2 on the top and a 3 on the bottom, so we get the same answer either way. So again, lots of nice things can work out here when we've got them underneath the radical, if it's something that we can simplify. And you may have been able to jump right to here. That's awesome if you can. Like 4 goes into both of those if you recognize that. But either way, we're going to get the same answer. Okay, so that's applying the quotient property in this direction. Let's see what happens when we go in the other direction. And I'm going to show you a couple different ways that you could do this. So on this one here, notice that we can't simplify radical 6 and we can't simplify radical 3. But look what happens if I put this underneath one radical. I get radical of 6/3, which is 6 divided by 3 is 2. So it's just radical 2. That is the answer. We're done with that. Now you could, and this is kind of interesting that it works this way, you could write this as radical 2 times 3 over radical 3. We could use the product property to break that into 2 separate pieces. And then notice that this is a radical 3 on the top and a radical 3 on the bottom. I can cancel those and I end up with radical 2. Now I think you'd agree with me that that first technique that we use, just applying the quotient property immediately and then simplifying, works out much better. But this is a valuable technique, so just kind of keep that in mind. All right, so let's come down here and let's do a couple of these using the quotient property for radicals. So on this one right here, although you could simplify each one of these, watch how quickly this works out. Let's write one big radical. Whoops. Radical 18 over radical 9. Those cancel to be a 2. We're done. It's just like that previous one that I did, all finished up right there. So if we take a look at this next one, we've got radical 30 over radical 16. Whenever you see a perfect square, it's not a bad idea to go ahead and simplify that. We used the other technique on this one, so let's see, this would be the square root of 16, which would be 4. This is radical 30. Let's check and see if we can simplify that at all. 30 would be 3 times 10, and 10 would be, let's replace that with a 2 times 5. So there's nothing that we could take out of there, so that is the answer. We're finished with that one. That's as simplified as it gets. And this next one's kind of interesting because we've got the square root of 10 over the square root of 32. We can simplify this, and I'm going to do this a couple of different ways, I think. So let's take a look at this right here. Let's write it as one big radical. So this is going to be a 10 on the top and a 32 on the bottom. Those are both even, so we can write this as, let's see, 2 goes in here 5 times and 2 goes in here 16 times. We certainly don't want to leave it that way. We really don't want to leave a fraction underneath the radical. So we're going to break it up into the radical 5 over the radical of 16. And again, this does not have a nice square root. That's simplified all the way. But the square root of 16, that works out to be a 4. So that's simplified. We're done right there. And notice how we use this technique of writing it as one big radical, simplifying that, and then breaking it apart again, using that quotient property of radicals in both directions. Okay, so let's take a look at this next one. We've got a 3 and a 4 on the top. And let's do this. We'll write this a little bit shorter. Let's write the 3/4 out front, and then we're going to write this fraction underneath. We're going to do 50 over 25. And look what happens here. 50 divided by 25 is 2. So this is 3/4 times, we've still got the radical there, 3/4 times radical 2, and there's the answer. So there we are. So again, we really don't want to have a fraction underneath the radical, and most of the time we don't want a radical in the denominator, so we kind of want to look to avoid those. So this is problem number 7 from the assignment. We'll take a look at that one there. On this one, looks a little bit different than the ones that we've had before, but again, you'll notice that this would be radical 3 times 5, and this would be 3 times radical 5. Now, I'm going to leave that there for just a second, but you'll notice that I can't simplify either one of those. There are no pairs of factors. So one way to do this is to put a 1/3 out in front. Okay, there would be a 1 on the top and a 3 on the bottom. Write one big radical, so we've got radical 15 here and radical 5 there. And then this does reduce, 5 goes into 15 3 times, so this would be 1/3 times radical 3. So the best way to do this is to write radical 3 over 3, and we're going to circle that answer. Now, that is the answer. I want to come back to that in just one second after I do this a different way. If you were to do this, I want you to take a look at how we're kind of mixing these properties together, because this is a valuable technique. We have a radical 3 times a radical 5. Remember, that product property says that if we've got a little multiplication problem underneath, so we could say if we have a radical of a product, then we can change that into the product of the radicals. We've got 2 little radicals there, and then I've got a 3 and a radical 5. And notice that I've got a radical 5 here and a radical 5 there. So again, we end up with a radical 3 on the top and a 3 on the bottom, so that's the answer. Now, one thing that people often try and do is they'll say, well, wait a minute, this is a 3 and this is a 3. Can't I cancel those off so I end up with a 1 or something like that? Okay, this is a radical 3. It is not a 3. So this 3 is underneath the radical. It's not even close to the number 3. If you were to type that into your calculator, you get like 1.7 or something like that. These cannot be canceled. You can't cancel something inside of a radical with something that's not underneath a radical. Just keep that in mind. You'll practice that more as the years go by, but that's a very common mistake. You're going to leave it this way. That's a radical 3. This one is a plain old 3. So we cannot cancel, okay? Can't reduce those, all right? So please keep that in mind. All right, good luck on the assignment. The next one is just going to be a mixing of those together, and then we'll get working on preparing for the unit test, and good luck on the assignment.